So today we are going to discuss another way of doing the authentication process, which will be able to recognize that who is who. So that process is known as, that method is known as with the help of authentication token. Authentication token is an useful alternative of the password, and it is a kind of a small device that generates a random value every time whenever it is being used, and become the this random value becomes the basis of the authentication. Now, the authentication token is a small kind of a device which contains processors, LCD display, battery, keypad, clock. All the things are available in this authentication token. And each authentication token is pre-programmed. It is programmed previously, and it has a very unique number, programmed with a very unique number, and that number is called random seed, or it is also known as only seed. And this seed is going to become the basis of ensuring the uniqueness of the output which is produced by the tokens. Now, uh, before we going to start how this authentication token is being used for the authentication purpose, the first and the foremost and the important thing is that the token and the servers are synchronized initially. And every time whenever the token is being used, it will generate a fresh password. You can say it as a password or a random number. And it used to do it periodically, because at a particular instant of time, if any client which is using authentication token and want to use that token, so it will generate a particular random number or the token. And the next time whenever it is going to use, it is going to give the password or the token differently. So that is why the token is going to generate fresh values every time whenever it is being used. So the same value is not generated. And these values which are generated at the client side, the same password or the same values are also generated at the server. And that is why token and the server are synchronized initially. So whatever way the token is working, the same way the server is going to will be working. If a particular password is being generated by a token at the client side, the same password will be generated at the server side also. So that is why token and servers are synchronized initially. Now, how it works. Now, as far as the concept of authentication token is concerned, whenever the authentication token is created, the corresponding random seed is generated by the token by the authentication server, and that is why since it is synchronized initially. Now, whatever is this seed value, the seed is stored or pre-programmed inside the token, and it will also work for the authentication purpose. So the seed which is pre-programmed and it is lying inside the token, and now this seed value has to be entered by the user, and it is stored in the user database of the server. Now, now as far as this seed is concerned, this seed can be considered as the user's password. Of course, the password is not the correct word at this particular instant, at this particular moment. So, the seed value through which it is being, whenever the corresponding to every ID, corresponding to every user, there is a certain seed value which is maintained at the server side. So how the server is maintaining with respect to the different ID, the seed value is being stored. Now, how we will use this token? Now, use of the token. Now, an authentication token automatically generates the random numbers, and that random numbers are also called as one-time passcode or one-time password. Better to say it one-time passcode. Now, this one-time passcode are generated randomly by the authentication token, and it is based on the seed value that they are pre-programmed with. Now, it is called one time. Why it is called one time? because it is generated and used once and then it is discarded. So whenever a user want to be authenticated, the user will get a screen on the it will get a screen, and to enter its user ID, and whenever it enters the user ID as well as the latest one-time passcode. Now, with this, the user will be entering the user ID and one-time passcode which is obtained from the authentication token. And this user ID and the passcode travels to the server as a part of the login request. Now, this value is not the seed value. It is the due to seed value. This one-time passcode has been generated by the authentication token. So once this one-time password has been generated by the authentication token, along with this ID as well as this one-time passcode is sent from the client side to the server side. Now, whenever the server is going to receive this information about the client information which it has sent, what it has sent? It has sent the ID as well as one-time passcode which is generated by the authentication token. Now, it is the duty of the server to go to the retrieval program, seed retrieval program, to find out the seed value corresponding to the ID Atul. Now, it finds the seed value Atul at 615091. So, this seed value from the user database, after seed retrieval program is over, it will send the seed value to the server. Now, since server has already received the user ID and corresponding to the user ID, it has also got the seed value. Now, server will be checking the password, and that is why it will be activating the password validation program. So the server password validation program, it will going to calculate the one-time password and checks the seed against the one-time password. So server has received the one-time password, server has received the seed value from the user database, and these two values are sent to the password validation program. Now, if this password is correct, means this, because whatever due to this seed value, whatever the authentication token which is available at the client side, it has generated one-time passcode as 156159191. It will also generate the same value against this seed value. So this password validation program is going to validate that against this CD, against this seed value, what is the one-time passcode. So it finds, if it finds that one-time passcode is 156159191, it says that the password is correct. Otherwise, it invalidates it. So this is how the server now, whenever it receives the password is correct, the server returns the appropriate message to the client. That login is successful. Now you can proceed. Now, a question can arise at this particular stage, that what will happen if the user is going to lose the authentication token. Now, there is nothing to find it, because it is very difficult to, if it is lost, it is lost. So to deal with this kind of situation, the authentication token is generally protected by 4-digit PIN. 4-digit PIN. And only that, whenever this PIN is entered, then only the one-time passcode can be generated. And that is why it is going to create the multi-factor authentication. Now, multi-factor authentication, we have 3 factors of authentication. The first is something that you know, that is the password or the PIN. The second authentication factor is something you have, such as your credit card or the identity card. And third authentication factor is something you are, your voice or the fingerprints. So based on this particular principle, the password is the one factor authentication, because it shows that something you know. Because you know something due to which you are able to be authenticated. But in contrast, as far as the authentication token is concerned, it is a 2-factor authentication. The first factor of authentication is that what you have something in the form of a authentication token device. And the second factor of authentication is to know the PIN. So even though your authentication token has been lost, until unless the person who has received it Until unless he is not having the PIN, it cannot be used, that authentication token. Similarly to that, if you have a credit card or the debit card, it is also creating two-factor authentication. Something you have and something you know. The something you have is the credit card or the debit card, and something you know is its PIN. So based on that, the two-factor authentication can be done. The third factor of authentication is the authentication which is the biometric authentication, in which you are going to recognize. So that is why the first factor is something you know, second factor is something you have, and third factor is something you are. So you will be recognized, then you will have something, and then you know something. Based on that, three-factor authentication has been made. Now, as far as the authentication tokens are concerned, it has two types. First is the challenge response token, and second one is time-based token. So let us know what is challenge-based. One by one, we will be discussing challenge response token, and second one is time-based. So first one is the challenge response token. The idea behind this challenge response token is actually the combination of the techniques which we have discussed earlier in the authentication process. That we have seed pre-programmed authentication token, which is a secret as well as the unique. And the fact is that the basis of the challenge response token, that the seed becomes an encryption key for in this particular technique. So how it works? So first of all, the user sends a login request, and whenever it sends the login request, it will send only the ID to the server. So whenever the server is going to receive this particular ID, the server will be activating its authentication program, authenticator program, by which it is able to match the ID Atul in the user database. If it finds that ID Atul is registered at that particular server, it will give the information to the server that ID is valid. Then what will happen? The server will activate the random challenge creation program to create a random challenge number. So the server is going to activate it, and this random challenge creation program will create a random challenge value, that is the random number. And this random number, which is created by the random challenge program, is given to the server. And from the server, this random challenge number is received by the client. So this is the second step in which the server creates the random challenge after receiving the ID of the client. Now, the step 3 says that user is going to sign this random challenge with the message digest of its password. So how it happens? The user will be getting a login screen in front, in which user will be writing its ID and the random challenge which it has received, and it is asked to write the response. Now, what will happen, as it is said that the random challenge has to be encrypted with the message digest of the password. So at this stage, the user reads the random challenge displayed on the screen. It first opens the token by using the token PIN, and then keys the random challenge which it has received from the server side into the token. So in order to do this, it has a small keypad, and with the help of token has a small keypad, and with the help of tokens keypad, it will be able to enter the random challenge value which it has received. Now the token is going to accept that random challenge which is being fed through the keypad by the client itself or the user itself, and it is going to encrypt it with the seed value. Now the seed value is already residing, and it is already known to itself. So the result is that the random challenge which it has received, this random challenge is fed into the token, and the token is going to encrypt that random challenge with the seed value. And the result will be displayed on the LCD display of the token. So what is the user going to do? User going to read the value and types it into the password field in the form of a response. And the request is then sent to the server as the login request. So how it is being done? So what is happening here? The original random challenge value it has received. The seed value it already knows internally. So it will feed this random challenge value into the authentication token, and this seed value is going to encrypt this random challenge, and the result is the random challenge encrypted by the token. So now the client will be sending the login request in the form of its ID and the passcode which it has been generated by the token, which it has received from the token. And this password and ID will go to the server side. Now the server is going to verify the encrypted random challenge which is received from the user, and the server is going to receive the random challenge which was encrypted with the seed value of the user authentication token. So in order to verify the random challenge, which is indeed encrypted by the correct seed, the server must perform a similar kind of operation uh, at the server side. So now there are two ways by which it can validate the value which it has received from the client. The server can decrypt the random challenge, encrypted random challenge which it has received from the user with the seed value, because server is also knowing the seed value. Server can retrieve the seed from user database, find the seed value, and random challenge is already available with the server. It can encrypt that random challenge with the seed value and then try to match whether both are equal or not. And if both are equal, the login will be successful. The other way of doing the same uh, alternative process can be the server can simply encrypt its own version of random challenge, and it knows the seed value. It will encrypt it. The encryption will produce the encrypted random challenge value, and then whatever random challenge value it has sent, it can be matched. So any one of this operation, any one of this mode can be used for the retrieval process and to check the validity of the passcode which it has been sent by the client. Now, if it is true, if then the login will be successful, the server is going to return an appropriate message back to the user. Now, this particular technique, that is challenge response tokens, has little bit problem. The problem with this scheme is the generation of the long string, because it may be possible that the seed value may be of 128-bit key, 128-bit random challenge which is also created is also 128-bit. So whenever the random challenge is being received by the user, so what it has to do, it has to 128-bit random challenge value has to be feeded into the authentication token. Then authentication token is going to make the encryption with the seed value, and again it is generating a 128-bit key, 128-bit passcode, and that 128-bit passcode which will be displayed on the LCD of the token, it has to be read by the user, and then it has to type on the response window. So this reading and writing, it seems to be a little bit complex, and that is why this particular random challenge response tokens are are little bit require more computational efforts, more reading process, more encryption process, and typing the random value and then typing the challenge value. So little bit difficult process. Of course, it's a valid process, but it is a difficult process. So this kind of disadvantage, which is the previous scheme is having, it is overcome by the time-based token. So it is a kind of an improvement of the challenge response mechanism, in which the user have to make three entries. First, it has to user have to enter the PIN to access the token. Then it has to read the random challenge from the screen, and then it has to key the random challenge value into the token, and then it has to read the encrypted random challenge from the LCD from the token, and then it has to write the passcode. So all these things are seems to be cumbersome process. That is why time-based token seems to be a better option than the random challenge. So what happens in the time-based token server? In this time-based token server need to send the random challenge to the user, and token need not have a keypad for entry, but it is going to use the time as the variable input to the authentication process. So as far as the authentication process is concerned, instead of receiving the random challenge, the server is not going to create a random challenge. Even though if it is going to create, it is not required to feed it into the authentication token. It is not required to get the value from the challenge in the form of a response and then feed it back. So in that case, instead of that, it will be using its time stamp for the encryption process. So how it works? The first one is the password generation and the login request. So what happens? The token is pre-programmed with the seed as usual as in the previous case, and the copy of seed is available with the authentication server also. So in the time-based token, we have to handle the situation differently in comparison to the challenge response. Now, these token do not require any user input. Instead of that, these token automatically generates a password every 60 seconds. For every 60 seconds, it is going to generate a password and displays the latest password on its LCD output for the user to read it and use it and send it to the server. So for generating the password, the time-based tokens use two parameters. First is the seed value and second is the current system time. So it performs some kind of cryptographic function on these two parameters to produce the password automatically. Now, the token which is displayed on the LCD screen, whenever a user wishes to log on, it looks at the LCD display and reads the password from there and uses his ID as well as the password which is given by the token and send it to the server. Now server is going to make the verification whatever it has received. What it has received ID as well as the password. So user is going to first activate the authentication program to obtain the seed value. So once this program is going to end and seed value is received by the server, it is going to it is activating the password generation program, and this password generation program is going to generate a password, and this password generation program is going to generate the password as well as it is going to encrypt the timestamp with the seed value because it is the requirement. That is what has been done on the client side. So with this seed value, the current time of the system is being encrypted and it will be getting a certain value. And this value after the password generation process is over is sent to the server. Now the server has already received a password from the client and the server has already created the password which is associated with the seed value of the ID. So if both the passwords are same, then the login will be successful. Otherwise, it will reject the. So if the login is successful, it will send the information to the client. Now, this seems to be very simple process, but it may be possible that it may create a difficulty because we are using timestamp and uh, due to and time-based tokens are which are being used. If we realize that what happens that the time window of generating the different password by the authentication token is 60 seconds. And what happens if the window of this 60 seconds is crossed from the time of the user login and the request which is being reaching to the server, and so the authentication will not be possible. So what will happen? So what will happen certificate. So if the time is not going to match, then there will be a problem, because it may be possible that the user is using a particular time as the 5:45:57 and after 57, and it will take some time to the request will be reaching to the server at the different time. So the password which is generated at the server, because there is a mismatch of the time, the both validity cannot be proved. So what happens, this particular problem can be resolved very easily, that if the time stamp is going to expire, then the user computer will be sending new login request by advancing its time by 1 minute or 2 minutes. If it is advancing it by 1 minute, so that if 1 minute is the time taken to reach the request, so that it can be matched. If it fails, it can be incremented by advances by 2 minutes. But it may be possible that there may be another difficulty, that if the time-based token don't have a keypad, then how does we are going to enter the pin? So to deal with this particular problem, user actually enters the pin in the login screen itself, and the software is intelligent enough to use in accessing the token. So, so this is all about the authentication based token.